Hey folks, welcome back. So let's build on what we did in example 1 by looking at an expression with a rational exponent. But now take note that the numerator is something other than 1. It's a different number. So keep in mind from example 1, the n, the denominator of your rational exponent, always translates to the index, okay? So if we've got m and n, I'm going to make them in lowest terms, and you have a to the m over n. If you go back to your rational exponents, we can split this. We can say, think of this as a to the 1 over n raised to the m. And keep in mind, when you have something like, if you ever have like x squared to the 7th, you're allowed to multiply those exponents, right? That's x to the 2 times 7, which is x to the 14th. And so if I was to look at this set of exponents, right? If I think about 1 over n times m, this is really m over 1. Well, whenever you want to multiply fractions, you multiply numerators, multiply denominators. That does get you back to m over n. So we're going to rewrite, if we have a to the m over n, rewrite it as a to the 1 over n, that fraction that rational exponent that we looked at back in example 1, and then handle the m part, all right? So we're going to place that numerator kind of off to the side. That'll be the second round of things we have to do. But let's handle the a to the 1 over n like we did in example 1, simplify that. And then whatever we get there, great, we'll raise that to the m power, right? And that's, again, pending that a to the 1 over n is a real number. We saw in example 1, you can't take even roots of negative numbers, all right? And if a to the 1 over n was not a real number, then a to the m over n is also not a real number. All right, so let's take a look at something like example 2a, 25 to the 3 halves. So what I'm going to do is I'm going to rewrite this as 25 to the 1/2 cubed, right? So I'm going to break that rational exponent up by taking the denominator with the numerator of just 1, right? 1/2. So I'll keep that 2, and then I'll put that 3 on the outside, because again, if we think about multiplying 3 times 1/2, right, that's 3 over 1 times 1/2, which is 3 halves. So I'm just splitting that rational exponent up. And then what I can do is I can think about this like I did in example 1. So I'll deal with the cubing in a second, but if I have 2 in my denominator, that's ultimately going to be the square root of 25, right? That denominator becomes my index. We know the square root of 25, right? That number is 5. And when I think about 5 cubed, right, if this right here is just 5, 5 cubed is 125. Okay? So let's take that same idea and apply it to 27 to the 2/3. Okay, so what I'm going to do is I'm going to look at 27. Instead of the 2/3, I'm just going to do the 1/3, right? Numerator of 1, keep that denominator, and then I will square it. All right, because again, side note, 2 times 1/3, right? 2 over 1 times 1 over 3 is 2/3. So I'm just separating this fraction into the 1/3 and the 2. Once I have that numerator of 1/3, we're back to what we did in example 1, right? That denominator becomes the index, so I'll do the cube root of 27, and then I'm going to square it. So that's the new part that we're adding on to this. We're going to back this up so that we have our number raised to a rational exponent where the number is 1, convert that to a radical, and then use that numerator as the next power, right? So cube root of 27, this right here is 3, so this becomes 3 squared, which is 9, okay? So I'm going to scooch this up, and we're going to play this out for a few more examples. All right, so let's take a look at negative 25 to the 3 halves, and compare that again to D, negative 64 to the 2/3. Here the negative is not in a parentheses, so I'm just going to do 25 to the 3 halves here, versus in D I'm going to have to do all of that, negative 64 to the 2/3. So here just the 25 is getting raised to the 3 halves, and I multiply it by negative 1. Here the negative 64, the entire thing is being raised to the 2/3. All right, so let's take a look at this. I'll keep the negative on the outside. All right, and then I want to do 25, numerator of 1, denominator of 2, then I want to cube it, right? So I'm going to separate 3 halves into a fraction of 1/2, right? Because I'll keep that denominator of 2, and then I'll cube it, right? The cubing being the second wave. All right, we know the square, or I should say 25 to the 1/2, that denominator becomes the index. All right, so I'm going to save that negative. I've got the square root of 25 and then cubed, right? So I'm going a piece at a time and I'm using PEMDAS. So keep the negative, the square root of 25 is 5, and then I gotta cube it, right? So 5 cubed itself is 125, and then I've got this negative 1 here, so negative 125, right? Now you can check all of this on your calculator, but the faster and more efficient we get doing it by hand, we can save ourselves some time. All right, so let's think about negative 64 to the 2/3. And then I gotta make sure this is a real number, right? So as I think about this, this is gonna be negative 64, right? And then I'm gonna make this to the 1/3, right? And then, and I'm gonna put brackets around it this time, I'm gonna square it. All right, and this helps me see a little bit more clearly that the index is gonna be 3. So I'm gonna have a cube root, and I'm allowed to take the cube root of a negative number. All right, so since that denominator was an odd number, I can make this work. If this denominator had been an even number, I actually would have gotten to stop the problem. I wouldn't have been able to complete it. So let's reconvert this. I've got 1/3 here, so that's gonna be a cube root. So I wanna look at the cube root of negative 64, and then I wanna square it. And if we go back to example 1, we actually directly looked at the cube root of negative 64. All right, and just to kind of remind you, you can look at it a couple of different ways. You can think of negative 64. So some people are going to think of negative 64 as negative 4 cubed, right? And some people are going to think of negative 64 as the opposite of 4 cubed, right? Negative 4 cubed, right? Or quote unquote, in parentheses, negative 4 cubed. Because ultimately a negative times a negative times a negative is negative. Or some people just want to look at 64, right? They want to break this and say, well, 64 was 4 cubed and I had a negative in front of it. So ultimately what's happening here, if I just extend this a little bit, I'm going to have the, let me put in brackets, right? I still have something squared, but ultimately this is the cube root of negative 4 cubed. That's going to cancel and leave me with negative 4 here. So I'm looking at negative 4 squared at this point, because I still have to answer or be responsible or take into account that numerator is 2. Negative 4 squared, well, negative 4 times negative 4 is positive 16, okay? All right, so let's scooch up as much as I can, give myself a little space so we can see all of these. All right, so I'm looking at these two. Now, again, I've got a negative in parentheses, so I want to pay attention to that and make sure it's a real number. And if it's not a real number, then I just stop the problem. Okay, so this is going to be, if I look at it, it's going to be negative 36 to the 1/2, right? And then I'm going to need to cube it because I'm going to split that fraction, right, with 1 over the denominator, and then I raise that to the numerator. Okay, so as I start to look at this, right, I'm going to now take that 2, because that's the denominator there, and I'm going to turn that into my index. So this is going to become, and let me leave this out here as something cubed, this now becomes the square root of negative 36, right? Because that index, that denominator was 2, so my index is 2. But I can't take the square root of a negative number, right? This does not exist, which is fine, just a matter of recognizing it. So this is not a real number. That's the little pound sign for number. I'll write out the actual word just so we have it. All right, and then scooching along to here, I got 64 to the 2/3. Okay, let's see what that is. So if I have 64 to the 2/3, on the upside, I don't have to deal with any negatives. Now, just so we're clear, the 64 is in parentheses, but since there's no negative around it, I also could have just written it without the parentheses. All right, so here the parentheses aren't necessary. It's fine that they're there, but they're just not necessary. So this is going to be 64 to 1 over that denominator, right? And then we're going to square it. Because again, 1/3 times 2 is 2/3. I'm just splitting that fraction. All right, 3 becomes my index. So this is going to be, and let me leave this as something squared. All right, we've got 64 to the 1/3. That is the cube root of 64, right? And maybe at this point you kind of have the cube root of 64 in your memory, or maybe you don't. But 64, if I rewrite this, 64 cube root of 4 cubed, right? And then I got a square. So cancels, right? Leaves me with 4 squared, which is 16. So just taking note between D and F, negative 64 to the 2/3 is positive 16, and 64 to the 2/3 is positive 16. Because ultimately, at the end of that, we were squaring something. So whether you square a negative or a positive, it's ultimately going to square to something positive. All right, thanks so much. Bye.